Have you ever wondered what it takes to dock a spacecraft with a moving target in space? What kind of challenges do engineers face, and how do they overcome them? Today, we're delving into the intriguing story of Boeing Starliner's trials and triumphs with docking at the International Space Station, or ISS. Buckle up, because this journey is full of twists, turns, and incredible problem-solving. Boeing Starliner, a key part of NASA's Commercial Crew Program, was designed to provide reliable transportation for astronauts to and from the ISS. However, the journey hasn't been entirely smooth. One of the most significant challenges Starliner faced was successfully docking with the ISS. The story starts with the Orbital Flight Test, or OFT, in December 2019. The mission aimed to demonstrate Starliner's ability to reach and dock with the ISS. But things didn't go as planned. Shortly after launch, a software glitch caused the spacecraft to enter an incorrect orbit. This anomaly prevented it from reaching the ISS as planned. The issue stemmed from a timing error in the mission clock, which led to a cascade of problems. Engineers quickly realized that Starliner was burning fuel at an accelerated rate, jeopardizing the mission. The Boeing and NASA teams immediately sprang into action, analyzing the situation and working around the clock to troubleshoot the issue. Although they managed to stabilize the spacecraft and bring it back safely to Earth, the mission was deemed only partially successful because the primary objective of docking with the ISS was not achieved. This was a huge blow, but it set the stage for a rigorous review process. Following the OFT, a comprehensive review was conducted to identify the root causes of the failure. The investigation revealed several software-related issues that needed addressing. Boeing committed to implementing extensive software upgrades and rigorous testing to ensure that the same problems wouldn't recur. The next critical step was the Orbital Flight Test 2, or OFT-2, in 2021. This mission was designed to prove that Starliner could dock with the ISS successfully. The preparations for OFT-2 included more than just software fixes. Boeing and NASA teams collaborated closely to conduct a series of simulations and tests to validate the spacecraft's systems. They also enhanced the communication protocols between Starliner and the ground control to prevent any discrepancies during the mission. The level of detail and care that went into these preparations was astounding. Every scenario was considered, every potential issue analyzed. Engineers ran countless simulations, each one meticulously designed to test the spacecraft's responses to various conditions and potential malfunctions. When the day of the OFT-2 launch arrived, the pressure was immense. The world watched as Starliner lifted off, and this time, everything seemed to go according to plan. The spacecraft successfully reached its designated orbit and began its approach to the ISS. But docking with the ISS is no small feat. It requires precise navigation and control, as well as seamless communication between the spacecraft and mission control. The approach is a slow and careful process, with the spacecraft gradually aligning itself with the docking port. Any error in this phase could result in a failed docking attempt, or worse, damage to both the ISS and the spacecraft. As Starliner approached the ISS, the Advanced Autonomous Docking System took over. This system, designed to guide the spacecraft into the docking port, had undergone numerous improvements since OFT. The system uses a combination of GPS, radar, and onboard cameras to navigate and ensure precise alignment with the ISS docking port. Despite some tense moments, where minor adjustments were necessary, the docking was ultimately successful. Starliner's ability to connect with the ISS marked a significant achievement, showcasing the resilience and determination of the teams involved. This successful docking wasn't just about overcoming technical hurdles. It represented a critical milestone for Boeing and NASA, proving that Starliner could fulfill its role in the Commercial Crew Program. The mission's success provided valuable insights and data that would be used to enhance future missions, ensuring even greater reliability and safety. The lessons learned from this mission were not just technical but also operational, providing a blueprint for future space missions. This success also bolstered confidence in the Commercial Crew Program, reinforcing the viability of partnerships between NASA and private aerospace companies. Following the successful docking, the Starliner crew began their mission aboard the ISS. This phase of the mission was just as crucial as the docking itself. The astronauts conducted a variety of scientific experiments, many of which were designed to improve our understanding of how the human body adapts to long-term spaceflight. These experiments covered a wide range of fields, from biology and human physiology to materials science and physics. The data collected from these experiments not only contributes to our knowledge of living and working in space but also has potential applications here on Earth, such as in medicine and technology development. Additionally, the crew performed maintenance tasks on the ISS, ensuring that the space station remained in optimal working condition. This included repairs, system checks, and even upgrading some of the ISS's equipment. The ability to conduct such maintenance is vital for the sustainability of long-term missions, particularly as we look towards future exploration missions to the Moon and Mars. Each task completed by the crew was a testament to their training and the robustness of the Starliner systems. The return journey was equally important and challenging. Re-entry into Earth's atmosphere is a critical phase of any space mission. The spacecraft must withstand extreme temperatures and forces as it descends. The Starliner's heat shield, designed to protect the capsule and its occupants, performed flawlessly. The spacecraft executed a precise deorbit burn, followed by a controlled descent and landing. The landing site was carefully chosen and prepared to ensure the safety of the crew and the spacecraft. Upon landing, recovery teams were on standby to quickly reach the capsule and assist the astronauts. This triumphant mission not only marked a significant accomplishment for Boeing but also solidified its place in the future of human spaceflight. It demonstrated that Boeing could deliver on its promise of a safe and reliable spacecraft, ready to transport astronauts on future missions. The successful return was celebrated not just as a technical success but as a proof of concept for the future of commercial space travel. The smooth re-entry and landing procedures were critical in ensuring the spacecraft's reusability and long-term viability. Looking ahead, the lessons learned from Starliner's docking challenges have paved the way for more ambitious missions. Future plans include using Starliner for crew rotations, cargo missions, and potentially even lunar explorations. The improvements made to the spacecraft's systems and the rigorous testing protocols established a new standard for space missions. These advancements are crucial as we aim to extend human presence beyond low Earth orbit, to the Moon, Mars, and possibly beyond. Each successful mission builds on the previous ones, incrementally advancing our capabilities and knowledge. In conclusion, the story of Boeing Starliner's docking challenges with the ISS is a testament to the perseverance and ingenuity of the aerospace community. It highlights the importance of meticulous planning, robust testing, and the ability to adapt and overcome unexpected obstacles. This journey, from setbacks to success, exemplifies the spirit of exploration and innovation that drives us to reach new heights. The determination and collaboration displayed by the Boeing and NASA teams demonstrate that even the most daunting challenges can be overcome with perseverance and creativity. Thank you for joining me on this exploration. If you enjoyed this deep dive into the challenges and triumphs of space docking, please like, comment, and subscribe for more fascinating stories from the world of space exploration. Until next time, keep looking up and dreaming big. The journey to the stars is filled with challenges, but it's these very challenges that make our achievements so remarkable. The future of space exploration is bright, and together, we will continue to push the boundaries of what is possible, one mission at a time. As we look to the stars, we are reminded of the boundless possibilities that lie ahead. Every challenge overcome is a step closer to our ultimate goal of exploring the cosmos and understanding our place in the universe. The story of Boeing Starliner and its docking trials will be remembered as a pivotal chapter in the ongoing saga of human space exploration, inspiring future generations to dream big and reach for the stars.